Hello and welcome to Maths with Jacob. This lesson will focus on problem solving, drawing a table. Drawing a table is a useful strategy because it can sometimes reveal relevant patterns, which could lead you to the correct answer. You can then work systematically through the table using any patterns that are obvious. Example 1. Susie is able to save $4 each week to buy her mum a birthday present. How long will it take her to save $30? This is a perfect example of using a table. So we keep building the table up until we get to our answer. Now, for the first week, she saves $4. For the second week, she also saves another $4, so that gives her a total of $8. For the third week, she adds another $4. That gives her a total of $12. And we keep adding $4 on. I think you can see that that's actually the 4 times tables. So can you see, each week you go up, you keep adding $4, and look what's happened here. We have 32 for the 8th week, which is over $30. So the answer, it will take her 8 weeks to save over $30. Example 2. Fred ran a cake stall for 8 days. On the first day he made $5. Every day after that he made $2 more than the previous day. How much money did he collect on the 8th day? How much money did he make in total? Okay, the problem says that on day 1 he made $5. There it is. On the next day he made $2 more, so that's $7. On the third day he made another $2 more, so that's $9. On the fourth day he made another $2 more, so that's $11. And you keep adding $2 on each day. See that? I'm just adding $2 on until I get to day 8. And look what's happened for day 8. He has collected $19. Okay? So then it says, how much money did he make in total? Well, these are the 8 days. 1, 2, 3, 4, 5, 6, 7, 8. So you just take all those numbers there in the table, you add them together, and he's made $96 over the 8 days. Example 3. Bob picks 12 marbles from a jar. Each marble is blue or red. For every blue marble he picks, Bob picks 2 red marbles. How many red marbles does Bob pick? Okay, so for the first pick, it says that for every blue marble he picks, Bob picks 2 reds. So there's 1 blue and 2 reds, which gives you a total of 3. If he picks 2 blue marbles, that means he picks 4 reds. That gives you a total of 6. If he picks 3 blue marbles, he picks 6 red. That's a total of 9. If he picks 4 blue marbles, 8 red, for a total of 12. So there's our total of 12. And the question says, how many red marbles does Bob pick? He picks 8. So Bob picks a total of 8 red marbles. Example 4. Tim and Mary are running in the cross-country carnival. Tim runs 3 kilometres every 15 minutes, and Mary runs 5 kilometres every 26 minutes. Who is running faster? Let's look at Tim's progress first. It says for every 3 kilometres, Tim takes 15 minutes. For 6 kilometres, he takes 30. For 9 kilometres, he takes 45 minutes. For 12 kilometres, he takes 60 minutes. and for 15 kilometres he takes 75 minutes. So that's very important. That's why I've put that in red. Let's look at Mary. For the first 5 kilometres, Mary takes 26 minutes. After 10 kilometres, she has taken 52 minutes, because you add another 26, or you just double that. After 15 kilometres, she takes 78 minutes. You just add another 26. So here we are. These are the common numbers. 15 kilometres here for 75 minutes. That's for Tim. 15 kilometres here takes 78 minutes. So you can see that Tim is running faster because he's taken less time to do 15 kilometres. Example 5. 1 litre of lemon juice is mixed with 5 litres of water to make a lemon drink. How much water is needed for 7 litres of lemon juice? Okay, let's have a look. So, it says 1 litre of lemon juice, which is there, is mixed with 5 litres of water. See there? Done. 2 litres of lemon juice is mixed with 10 litres of water. 3 litres of lemon juice is mixed with 15, and so on. 4 is mixed with 20. 5 is mixed with 25. 6 is mixed with 30. And 7 litres of lemon juice is mixed with 35 litres of water. So 35 litres of water are needed for 7 litres of lemon juice. See how easy this is with a table. Example 6. There are 6 swimmers in a relay race, or in a relay team. The first team member swims 400 metres, and each subsequent team member swims 50 metres less than the previous swimmer. How far does the last team member swim? So what that's saying is, the first swimmer, so swimmer 1 swims 400. Swimmer 2 swims 50 metres less, so that's got to be 350. Swimmer 3 swims 50 metres less, so that's 300. Swimmer 4 must swim 250. Swimmer 5 swims 200. And swimmer 6 swims 150 metres. So the last swimmer, the last team member, swam 150 metres. So you can definitely see how tables are very, very convenient, and it's a great way of solving problems. If the table suits, that's what you use.